Hello, I'm Paul Beckwith, and of course, this is Shackleton. He's a bit more content right now. He didn't like being a neck warmer today. Normally, he's pretty cool with that. But anyway, I'm going to continue my discussions in the previous video on the J.P.Morgan economic research report that came out January 14th. So, about a month ago. It was an internal document, but it's come public in the last few days. It's called Risky Business, the Climate, and the Macroeconomic. So I'm going to talk about some of the highlights of this report. Overall, it's a very good read. I highly recommend that you Google the title, get the document, and have a read. It's a good summary of bit of climate science, how human activity releases CO2. Some of that CO2 is, absorbed in the oceans and soils, but, a good chunk of it ends up in the atmosphere, raising atmospheric concentrations, and that leads to a temperature rise. And that temperature rise, is uneven across the planet and leads to climate change, increases of extreme weather events, etc. And it's the rate of the rise that is the most significant thing. So it talks about all of these things, and then it talks about different models that look at how GDP will be affected, among many other things. But it does address the direness of the situation, and there's some very powerful statements in there about something has to change, for the human race to survive, things like that. Okay, so I'll go to where I left off in the last video. Okay, so like I said, it talks about some of the climate science, the atmospheric concentration of CO2, parts per million, okay, and how the CO2 concentration and temperature over 800,000 years, basically track each other. So the blue is the CO2 and the temperature is the orange. Talks about global mean temperature anomalies. Okay, how temperature is rising. There's these Intergovernmental Panel on Climate Change, RCPs, Representative Concentration Pathways. So this is a very high emission scenario, and this is what we can expect. If you follow these scenarios, this is what we can expect in 2100. Huge temperature rises. Okay, this is the greenhouse gas emissions, gigatons of CO2. So in 2017, we put out 52 gigatons of CO2 equivalent. And if no new policies are enacted, emissions would rise to 60 by 2030 and 70 by the end of the century. So following this plot here, business as usual. To follow a 2 degree C pathway, we need a significant drop, and we need an even larger drop to have any chance of 1.5, although many people, including myself, think 1.5 is not attainable anymore. Okay, and then you can look at the total greenhouse gas emissions, what we would need in order to meet the Paris 2 degrees Celsius objective, significant throttling back of greenhouse gas emissions. This is CO2 and sea level, how they track over time. And these are worldwide extreme weather events. So this is a number of events per year, and you can see how it's scaling up significantly. Very, very non-linear, very, very sharp rise that kind of kicked in from, around sometime between 2005, 2010, huge uptick in worldwide extreme weather events. And that's ongoing. And then there's, climate change, the process, how, our human activity increases emissions, the carbon sinks take out some of the emissions. We get levels of CO2 in the atmosphere. There's fast feedbacks, slow feedbacks, etc. Okay, I'm not going to go into all of the details here, but there is something called the Kaya identity, and I hadn't heard of it called that. But greenhouse gases are basically the population growth. The four key drivers of emissions of CO2. Population growth is P times the GDP per capita, GDP over P, so the P's cancel out, times the energy intensity of the economy, which is energy over GDP. So now the GDP cancels out, and if you and the emissions intensity of the energy production, so the greenhouse gases put out per energy, the E cancels out, you're left with greenhouse gases. So these different factors, depending on how they grow, determine the overall emissions. And this shows some of the evolution of these emissions. Okay, there's lots and lots of data in here, and I could spend many, many videos going over this, but I just want to give you a flavor of things. So it talks about the carbon sources and carbon sinks in the ocean sink, the land sink, land use changes, and then the gigatons of CO2 that is produced annually. Of course, we're losing global tree covers. The loss is increasing, also upticked since about 2009, 2010. Concerning rise, this is a major sink, a major sink for carbon. And then cumulative CO2 emissions to temperature increases. So we're at about 415 parts per million now. Okay, in 80 years, if we're putting out about 2.2 ppm per year, you'd have to add 160 to the 415. That would give us 575. Or if it's about 3 ppm per year rise for 80 years, that's 240. Added to 415, the present, that would be about 655. Okay, so we're in this sort of range here. This is the trajectory that we're on, and there's no way that we could hold even 2 degrees Celsius from there. Now it talks about, from a CO2 concentration to a temperature, how do you arrive at that? You need to look at the equilibrium climate sensitivity. And this is if you double the, so a doubling of CO2 concentrations would involve a rise from the pre-industrial average of around 280 to 560. With CO2 concentrations already around 410, they're actually 415 now, a doubling from pre-industrial times will likely occur by about 2070. Okay, so that would be, add another 150 to this in 50 years, so that would be about a 3 ppm per year rise on average would give us this, we would reach this doubling by about 2070. And then the range is 1.5 to 4.5 degrees Celsius. Now this is within the 1 sigma, or 68% of the chance probability, with the sensitivity is in this range. But of course you need to look at the tails, and it's likely that it's even much higher than this. Okay, and it talks about fast feedbacks and slow feedbacks, and some different studies that talk about the things. One thing it says here is slow positive feedback mechanisms include changes to atmospheric circulations. I have to disagree with that. I mean, the jet stream is shifting already. It's happening very, very fast. So that's a fast feedback. But that feedback, the jet stream shifting, atmospheric circulation, is not even in any of these feedbacks. So it includes the fast feedbacks, water vapor, clouds, Arctic sea ice glaciers. It talks about the slow feedbacks, Greenland and Antarctic ice sheets, the AMOC shift, El Nino increasing in amplitude, the ocean convection reducing in strength, permafrost releasing CO2 and methane, reducing the carbon sinks, ocean in particular, the Amazon rainforest dieback and boreal forest dieback. These are slow feedbacks, but it has nothing about the jet stream feedback, so they need to be included in that. It talks about, it gives quotes from various people. So, Stefan et al. Suggests 2 degrees Celsius is a dangerous threshold because of the risk that a 2C warming could activate important tipping elements, raising the temperature further to activate other tipping elements in a domino-like cascading feedback that could take the Earth system to much higher temperatures. Remember, this is in a report from J.P.Morgan. And it talks about, Hansen's work a lot. It talks about sea level rise. It talks a little bit about Arctic sea ice. It talks about the distribution of these curves. So if the distribution of the ECS, the equilibrium climate sensitivity, is normal, there's a 4% likelihood that the temperature increase would exceed 6 degrees Celsius, and a negligible likelihood that it would increase 12. But if it's a Pareto distribution, the tails are fatter, there's an 8% likelihood that the temperature increase would exceed 6, and a 1.1% likelihood that the temperature, 1.1% likelihood that it would exceed 12. And I like how it says, given that a 12C temperature increase would create huge challenges for the survival of the human race. I mean, this is, game over. 12 degrees, 5, 6 degrees, probably game over. 4 degrees possible. I mean, we need to really assess, all of these temperature rises and the likelihood that we can, look at what we've had already. We've just had, just over 1 degree, 1.2 degrees, and we're already getting huge disruption around the world because of climate change. Okay, then they do, economic. Okay, well then there's some, this is interesting, past historical experiences. So we're at 410. We've risen 1 degree. Mid-Holocene, we were at 260 parts per million, 0.75 relative to pre-industrial. The Eemian, 6 to 9 meters of sea level rise, 1.25 degrees temperature rise relative to pre-industrial. Mid-Pliocene, 2 to 3.5. Mid-Miocene. So we're going back, with the temperature rises projected, for the end of the century, we're reaching back 4 million years, 16 million years, unprecedented type situations. And then, there's different models that look at the estimates of climate change on GDP. Now, these models are all, in my opinion, way, way too low. I mean, look at this. Global mean surface temperature increase of 6 degrees Celsius. There's only one model looking at it, and it estimated a drop of GDP of 6.7%. Okay, an impact. I mean, do you think anybody will still be, existing on the planet? Will we have any civilization with these sort of temperatures? So those models are and they acknowledge the economic impacts are way too small. So we need more realistic modeling by economists as to, what will happen. Okay, so there's lots of financial stuff, and then it talks about climate change and health, and it talks about climate change and the projection, so internal migration, climate migrants within countries, climate migrants across borders, and it actually says that there's 1 billion migrants globally at the moment, 75% estimated to be internal. So it does acknowledge all of these things. It talks about climate change and conflict, ecosystems, survival, and where, how it basically, in terms of what it says that we need to do is we need a global carbon tax, but it says that's not likely to be brought in. I just want to go, it does mention also geoengineering, both carbon dioxide removal and solar radiation management. And then in the conclusion, it says, we've got business as usual is not acceptable. Okay, thanks for listening.